Sure. So today we'll see the sums based on or the problems based on mechanical property of fluids. So there are more than 10-12 sums based on the different formulas comes under the mechanical property of fluids. So sums is not that much difficult. So based on formula only. If you know the given, if you know what to find, and if you know the formula, you can easily find. Okay. And calculation also not require that much log table. So you can directly multiply and divide, we'll get the answer. So your topic सबसे easy है और जो problems basis पे देखा. So we'll start with the एक sum. So today's topic is the mechanical property of fluid. So let's start with the first sum. So what is the first thing they are asking? You find the pressure 200 meter below the surface of the ocean. If the ocean, if a pressure on the free surface of liquid is 1 atmosphere. ठीक है उन्होंने ये दिया इंटेंसिटी ऑफ वाटर भी दिया सी वाटर का. So let's what is the given. So यहाँ पे given दिया what is the density of sea water. So I can get density of sea water, that is 1060 kg per meter cube. So these are the given. Then उन्होंने दिया distance, okay, or we can call it as a height. It's a below, but formula में we use height only. So it's a below height or above height. चलिए. So height is how much? 200 meter. Okay. Then what is the given? The pressure is given. The pressure is how much? 1 atmosphere. So 1 atmosphere means how many pascal? We can write 1.013 into 10 raised to 5 pascal. So 1 atmosphere means 1 ATM not लिखो. We need to convert into pascal. 1 atmosphere is equal to how many pascal? The other. So 1.013 into 10 raised to 5 pascal. Okay. So initially pressure कहाँ पे था? Surface of ocean पे. Then बाद में कहाँ पे गए? नीचे गए. ठीक है? Sure. So let's start with this sum. So what is to find? Find क्या करना है? यहाँ पे to find. I write the to find. So हमें find out क्या करना है? That is the pressure. So pressure on the free surface of liquid. Liquid के surface पे कितना pressure है वो find out करना. So we call that as P0 because it's inside the ocean, no? Or we can say it's on the surface of the ocean. So the surface of liquid we find. So this is P0. This O stands for ocean. So how to solve? So we'll use this formula. Which formula? This. P is equal to P0 plus H density and acceleration due to gravity. So what is P0? It's a 1.013 into 10 raised to 5 plus. And what is H? H is a 200. What is the density? Density is 1060. And G is how much? G is 9.8. Okay. So if you multiply all the things, it's a 1.013 into 10 raised to 1. Plus if you multiply all the things, ये सबको अगर multiply किया आपको, okay? So the answer is 2077600. ये आंसर है. क्या आएगा? 2077600. So this is the answer. If you multiply all the things, लेकिन यहाँ पे 10 raised to 5. So you need to convert this parameter into 10 raised to 5. Then only you can do the addition. तो अगर मैंने इसको 10 raised to 5 में convert किया, it's a 1013 into 10 raised to 5. Plus how to convert this into 10 raised to 5? 20.776 into 10 raised to 5. Both are in 10 raised to 5. So you can directly do the addition. Okay? Directly addition कर सकते. So let's do the addition. So 20.776 and 1.01. If you add it, it is 21.789 into 10 raised to 5. And what is a unit? It's a pascal only. You can write a pascal into Newton per meter square also. So 200 meter below, अगर आप ocean के गए, then what is the pressure? The pressure is this one, 21.789 into 10 raised to 5 pascal. We can also write in terms of Newton per meter square. Both are correct. Okay? Simple था. Just एक formula use किया and simple calculation use नहीं किया. This formula use किया. Simple calculation. There is no recurrent or any log. Same sum आएगा. It will be more easy. Okay. So the first sum हुआ. Let's start with the second. Okay. Sure. So let's say the second one. And in a hydraulic lift, the input piston has a surface area of 30 centimeters square. It's a ratio 2. And the output piston has a surface area of 1500 centimeters square. If a force of 25 Newton is applied to the input piston, calculate the weight on the piston. Output piston. See, यहाँ पे given क्या दिया? Input and output के term. So we consider input as a 1 and output as 2. So what is the initial area? Initial area is 30 centimeters square. इसे convert करते मीटर में. So 30 into 10 raised to minus 4. तो ये तो आना ही चाहिए. Then what is the area to? Area to become 1500 centimeters square. By applying the input piston, by applying the pressure from the input piston, area बढ़ गया. So it will become 1500 into 10 raised to minus 4 meters square. This is second area. ठीक है. Convert नहीं किया तो भी चलेगा. You can directly because ratio में. What is the force one? So the force one is we have to find the force. Weight पूछा मतलब force to find out. Force one is 25. And what we need to find? We need to find force two. ये find out करें. ठीक है. So formula क्या use करेंगे? Formula is very simple. See, pressure is equal to force upon area. So यहाँ पे pressure कुछ भी नहीं है. That means a constant. So I can get P1 F1 A1 is equal to P2 F2 A2. So दोनों pressure same मतलब F1 A1 and F2 A2 both are same. So let's use this formula. So यहाँ पे solve करता हूँ. So which formula are you using? F1 by A1 is equal to F2 by A2. तो मैंने ये formula use किया. ठीक है. So what is F2? F2 is equal to F1 into A2 divided by A1. Okay, so what is F1? F1 is a 25. No need to write in the meter square. We'll directly put in the centimeter square because ratio is cancel you. So A2 is 1500 and A1 is a 30. So we can simply divide it. This 0 get cancelled. 3 ones are 3, 3, 5, 50. So 25 into 5. So 25 into 5 is 125. This is 0. So what is the pressure? What is the weight or what is the force on the output? And F2 is 1250 Newton. Simple. एक formula based. Simple. This is answer. It may come for 2 marks. 2 marks ले or may for 1 mark also. Okay. Simple answer. This one is clear. Sure. So let's see the third one. Second one. Let's move for the third. This is the third sum. Okay, simple. So all the sums in this chapter are based on formula. So just find out what is the given and what is the to find. And if you know the formula based on this section, you can easily solve. Now the next step is based on if we have one drop. See a drop of mercury. Okay, soak me. Drop of mercury of radius 0.2 centimeter is broken into 8 droplets of the same size. Find the work done if a surface tension of mercury is a 435.5 centimeter. So let's write what is the given. This is your third sum. So let's write what is the given. See given उन्होंने दिया है. Initial radius कितना है? जब drop बहुत बड़ा था, initial radius is 0.2 centimeter. You can convert into meter. It's a 0.2 into 10 raised to minus 2 meter, and that we can get 2 into 10 raised to minus 3 meter. What is the initial radius? नंबर ऑफ ड्रॉपलेट्स कितने में 8 मतलब ये ड्रॉप कितने में डिवाइड होगा डिवाइडेड इनटू 8 1 ठीक ऐसे 8 में डिवाइड देन व्हाट इज द सरफेस टेंशन हियर द सरफेस टेंशन इज T that is 435.5 डाइन सेंटीमीटर ठीक है नाउ डाइन सेंटीमीटर मतलब उसको कन्वर्ट करना है न्यूटन मीटर में सो व्हाट इज वन डाइन को कन्वर्ट करना है न्यूटन में से 10⁻⁻5 न्यूटन and नीचे अगर 10⁻⁻2 मीटर ये 10⁻⁻2 ऊपर गया so it will become positive and -5 plus 2 it will become 10⁻³ न्यूटन पर मीटर ठीक है so ये हो गया टेंशन का सरफेस टेंशन का लेट्स मूव फॉर द नेक्स्ट वन और कुछ इनपुट दिया है क्या नथिंग so what we need to find so we need to find the work done ये फाइंड आउट So work done का फॉर्मूला सबको पता है that is a T into dA. There is a change in the surface area ना. Okay. So let's see So T into dA we can find by the dA. Okay, sure. So let's go for it. So these are the given. So I'll start with the answer. Solution. See, what is the initial formula? W is equal to T dA. So what is the dA? Whatever the change in the area of that circle, that rate of that bubble, that drop. Okay. So see, this is the initial drop. उसके बाद it divide into 8 droplets. ठीक है, सबको add किया. Then again it will become the major droplet. मतलब volume change हुआ क्या? Change क्या हुआ? Area change हुआ. because सबका area change होगा ना. All are same, लेकिन area change हुआ. This is a bigger area. This is small area. Okay? But if I add all of them, we can form the new droplet as a major one only. So area change हुआ, volume नहीं. Volume is same. Will use the same formula. See, मुझे पता है कि जो drop बड़ा था, that time the radius is 0.2. Drop छोटा हुआ, that time उसका कितना radius है? That I don't know. So what I'll do? Volume is the same. So what I'll get? So volume of single drop. Okay, जब drop था, it's same as volume of single droplet. Droplet मतलब when you divide into 8 ना, so that time जो जितने droplets है, उनका volume I can write here 8. Okay, I will write 8. What 8 indicate? That is a number. So let's take it. This is 4 by 3 pi r cube, and this is 8 into 4 by 3 pi small r. So 4 by 3, 4 by 3 cancel, pi get cancel. So what is your? I want to find r cube. So what is r cube? It's a capital R cube divided by 8. Sure. अगर मैंने cube root किया, if I take a cube root on both sides, तो मुझे r क्या मिलेगा? It's a cube root of r cube by 8. So what is the answer? It's r by 2. Sure. So what is r? R is a 2 into 10 raised to minus 3. This is 2. 2 get cancelled. So what is smaller? 10 raised to minus 3. जब drop बड़ा था, that time what is the radius? 2 into 10 raised to minus 3. And जब drop छोटा हो, तो what is the radius of one droplet? That is a 10 raised to minus 3. So I can find the area. So यहाँ से आपको small r मिलेगा. ठीक है? यहाँ पे number of droplets कितने थे? 8. So 8 आए. Number of droplets is 10. You can write 10. ठीक है? Sure. So let's see the next one. ये तो हो गया. So let's start with the answer. Work is equal to T into dA. And what is the area of the drop at the net sphere only? So let's take. So T. So what is the initial one? So I can write the anything. Let's take first droplet one. So 8 droplets total area. 8 droplets and सबका कितना है? 4 pi small r square minus. It's a single only. So 1 into 4 pi capital R square. दोनों का कितना difference है? That we need to write. Change the area. Okay. So we know what is the area. This one 435.5 into 10 raised to minus 3. Okay. So if I do 8 minus 1, यहाँ पे r square भी है. So let's put the value. So 4 pi into r square. R square is how much? 10 raised to minus 3. It becomes 10 raised to minus 6 minus 4 pi into r square. R square is 2 into 10 raised to minus 3. It will become 4 into 10 raised to minus 6. Okay. So I can take 4 pi as a common. So अगर मैंने 4 pi common लिया, so what is inside? 8 into 10 raised to minus 6 minus 4 into 10 raised to minus 6. You can also take the 10 raised to minus 6 as common. So answer क्या है? 435.5 10 raised to minus 3. 4 into pi is a 3.142. And this will become 8 minus 4 is a 4 into 10 raised to minus 6. If you multiply all the things, सबको अगर multiply किया, this part, this part, this part, this part, सबको multiply किया, then what is your final answer? The final answer will become 2.189 into 10 raised to minus 5. And it's a work done. So what is the unit? That is joule. No need to use any log table. Directly do the multiplication. So 4 into 4 is a 16. Okay. Then 3.14. Then 435.5. We'll get the answer. थोड़ा सा multiply करना होगा. But the same sum है, तो you can also go through the answer. क्या answer का निकालना? So you can cross check. 2-3 बार सॉल्व किया तो हाँ याद रहेगा, इसका आंसर 2 पॉइंट समथिंग है, why can answer yes, to match it. So how many work done is required to convert the single drop into 8 droplets? This is the work done. कितना work done को करना पड़ेगा, that is 2.189. So this formula is the same. Okay, so let's just go through the sum. The third sum is clear. Let's move on to the fourth one. So we'll take the same sum इसके ऊपर, we'll take that sum. सेम सम. यहाँ पे उन्होंने क्या पूछा है, 27 droplets of water, each of radius 0.1 millimeter. So what is the given here? So number of droplets कितने हुए, 27, and radius कितने उसका, it is r is equal to 0.1 millimeter. So small r क्यों लिखा, capital क्यों, let's see. This is 10 raised to minus 3 meter, so I can write 10 raised to minus 4 meter. And coalesce into the single drop, मतलब 27 droplet एक बड़ा drop में form. तो यहाँ पे छोटा r क्या आएगा, 0.1, because what is the radius of small droplets, that is r. जो बड़ा होगा it will become capital R. So right now I don't know what is a capital R. We need to find. T is 0.072 Newton per meter. So no need to convert to time. It's already given in the Newton. So it's 10 raised to minus 3 Newton per meter. Okay. Again मुझे find out क्या करना, that is work only. And the same formula, T into D. Right now I don't know what is capital R. We can find it, capital R. Okay? These points are given. So let's start with the answer. See, volume of single drop is same as volume of single droplet. How many droplet? 27. So I write 27. So it's a 4/3 pi capital R. Volume is same. So 27 into 4/3 pi small r. So 4/3 get cancelled, pi get cancelled. So what is the remaining? Is r cube is equal to 27 small r. So if I take a cube root, so क्या होगा? 27 r. So what is the answer? 27. This is 27. So 27 किसका आता है? The answer is 3 ना? 3. So it's a 3 r. So it's a 3 into, and what is the radius? It's a 10 raised to minus 4. So what is the area of the bigger circle or bigger drop? That is the 3 into 10 raised to minus 4. That is the radius. Okay, 3 into 10 raised to minus 4. Okay? Sure. So ये होता हो गया meter radius of the bigger one. We'll go for the final answer. So what we require, work done, T into D. So again we'll subtract the surface area. T is how much? 72 into 10 raised to minus 4. यहाँ पे क्या आएगा? See what is the initial area? So we can say यहाँ पे कहाँ से कहाँ तक जाएगा? 27 to bigger. So I can write 27 into 4 pi r square minus 1 only 4 pi capital R square. So you open it. So यहाँ से what we can take count? So 72 into 10 raised to minus 3. I can take as 4 pi common. So यहाँ पे क्या आएगा? 27 into r. R is how much? It's 10 raised to minus 4. So it will become 10 raised to minus 8. और यहाँ पे r square 3 into 10 raised to minus 4 ना, so it become 9 into 10 raised to minus 8. Short, simple. So 27 minus 9 will become 80. 72 10 raised to minus 3 4 pi, it will become 18 into 10 raised to minus 8. If you solve it properly, if you multiply all the things, take 72 into 4 and this will become 3.144 and 18. So if you do this multiplication, the answer is 1.629 into 10 raised to minus 7 Joule. And this is your work. Okay? So your multiplication correctly. It will take just 2 minutes. Okay? And this one will be for 2 marks. Simple. If you solve it properly, तो दोनों सम जो हमने देखा, previous में क्या था? 1 is a divided into 8. अभी क्या हुआ? 27 is a united into 1. So this one is a divided and this one is united. Okay? Same formula is the same. Okay? Sure. So we'll go for the next one. So what is the work? 1.629 into 10 raised to minus 7. Yeah, answer. We'll go for the next one. So we're done with the force one. Let's see the next one. So this one is the fifth sum. So next they are saying how much work is required to form a bubble of 2 centimeter radius from a soap solution having the surface tension of 0.07 nanometer. Sorry, Newton per meter. Okay. So let's get the given. So how much work is required to form a bubble of 2 centimeter? Convert into meter, tension kitna diya? 0.07 Newton per meter. So we can convert into 7 into 10 raised to minus 2 Newton per meter. Okay. We need to find same thing. How much work done is required? To find. So work done is same TDA. How much work is required to form a bubble of 2 centimeter radius? मतलब यहाँ पे initial area कुछ दिया है क्या? Nothing. We have to just design one bubble of 2 centimeters. So initial there is nothing. पहले क्या था यहाँ पे single bubble we can divide into 8 or 20 cent bubble we can divide it united into 1. So initial and final ऐसे क्वेश्चन था. यहाँ पे initial कुछ भी नहीं. We have to just design final. So what is the initial area? The initial area is 0. So we can consider that initial area is 0. Okay. Second thing, it's a bubble. It's not a drop. So for every bubble, there is a 2 surface areas. Okay. So whenever you are finding that area, you have to multiply by. These are the. Let's see the next one. So how to get the answer? So initial surface area कुछ दिया क्या उन्होंने कुछ बोला भी नहीं कि इतना droplets था इतने में convert. You just say कि one droplet, one bubble form, not a drop. So initial surface area. So you can get initial surface area of bubble is 0 because कुछ दिया नहीं ना information. And we can't also find. कुछ find भी नहीं कर सकते. Next, for every soap bubble. So there are 2 surfaces. That is the inner and outer. So जो final surface area जो आपको जो हमें डिजाइन करना है, that final surface area of bubble, it's 2 times the actual area. So what is a 2? 2 into 4 pi r square. So what is the answer? Write it. 2 into 4 into. Next, what is the pi? That is a 3.142. And what is r square? It's a 2 into 10 raised to minus 2. It is a 4 into 10 raised to minus 2. Okay. So you can write this one. That is 460. Okay. So if you multiply here, so if you multiply, it's a 4 into 4 is 16. 16 into 2 and then 3.1. So if you multiply all the things, the answer जो आने वाला है, so the answer is 100.544 to 10 raised to minus 4. This is your actual area. Okay, this is the actual area, final surface area of bubble. Okay, so we can say it as a dA. Can say it as a dA because initial surface area 0 and initial surface area is 0. So we can write as 0, 100 from this one. So then go for the answer. So it's a W is equal to TD. So initial surface area is 0. So write जो हमें दिया हुआ it's a 7 into 10 raised to minus 2 और ये कितना है 100.544 into 10 raised to minus 4 because of square 1. This is 4. Now if you do the multiplication, so let's do the multiplication. So answer कितना है 703.808 into 10 raised to minus 6. Sure. So this is your joule. So how much? The answer 703.808 10 raised to minus 6 joule. So this is your final answer. Simple come because initial area कुछ नहीं दिया. This is 0. So we can consider the initial area 0. And 2 times क्यों multiply किया? Because it's a bubble. So whenever there is a bubble, you have to multiply the area by because we have the 2 surfaces, in outer and inner. So that time, अगर drop होगा, there is only one time. But soap bubble होगा, that time this dA should be multiplied by 2. ठीक है? So let's go for the next one. A rectangular wire frame of a size 2 into 2 centimeter deep in a soap solution taken out. The soap film is formed. The size of the film is changed to 3 centimeter to 3 centimeter. Initially again, finally again. Again, it's a soap bubble. Okay, soap film. Calculate the work done in the process and the surface tension. Same thing. So what is the initial area? So we can directly write, no need to find the radius because it's a rectangular frame. So area is 2 centimeter into 2 centimeter. So it will become 4 into 10 raised to minus 4. What is the area to? It's a 3 centimeter into 3 centimeter. So that will become 9 into 10 raised to minus 4. Okay. And what is the tension? Tension is a 3 into 10 raised to minus 2. So again, क्या find out करना? It's a work. So work is equal to TT. But again, it's a soap bubble, soap film. So 2 से multiply करो. That will do in the next step. So this is your input and this is your proof find. So let's go for the solution. So W is equal to TT. I know what is a T. That's a 3 into 10 raised to minus 2. And how to find TA? It's a 2 time area, both the area, A2 minus A1. So 2. So what is a A2? A2 is a 9 into 10 raised to minus 4. And A1 is a 4 into 10 raised to minus 2. So what is the answer? It's a 6 into 10 raised to minus 2. And this will become 5 into 10 raised to minus 4. So what's the answer? 30 into 10 raised to minus 6 joule. This is the answer. What is the W? Work done how much required? To increase the area from 2 centimeter to 2 centimeter to 3 centimeter to 3 centimeter under the tension 3 into 10 raised to minus 2 is a 30 into 10 raised to minus 6. Simple. Okay. So all the problems comes under the work and its over. Let's move for the next one. 27 वाला भी हो गया. An air bubble of a radius 0.2 millimeter is situated just below the water surface. ठीक है? Calculate the Gauge pressure. The surface tension of water is given. Gauge pressure find out करना मतलब उसका formula different. So radius is 0.2 millimeter. Millimeter मतलब 2 into 10 raised to minus 3 आणि 0.2 into 2 into 10 raised to minus 4 मीटर. ठीक है? टेंशन भी दिया 7.2 into 10 raised to minus 2 Newton per meter. And what we need to find? We need to find the Gauge pressure. Okay? So Gauge pressure, Gauge pressure is represented by delta P. Okay? So Gauge pressure is represented by delta P. So what is the formula? Let's see. Answer. Gauge pressure is a delta P and the formula is a 2T by R. Simple formula. Tension divided by radius. So 2 into T. T is how much? It's 7.2 into 10 raised to minus 2. What is the radius? It's a 2 into 10 raised to minus 4. Because millimeter is 10 raised to minus 3. So 2 to get cancelled. 10 raised to minus 4 goes up. So it's a 7.2 into 10 raised to plus 2. Because minus 2 plus 4 plus 2. So what is the delta P? 7.2 into 10 raised to 2. So we can write as a 720. Na? We can write 720. यहाँ पे दो है ना, एक और आ गया और एक और. So this is 720 Newton per meter square. So how many Gauge pressure is required for this air bubble? That is 720 Newton per meter square. You can also write in Pascal. The correct. Okay. Sure. So let's go for the next one. Calculate the rise of water at height inside a clean glass capillary tube of a radius is 0.1 millimeter. So radius of the capillary tube is 0.1 millimeter. When immersed in a water of a surface tension 7 into 10 raised to minus 2. Okay. The angle of contact between the water and glass is 0. The density of water is given and the G is given. That is 9. So let's write the given first. So what is the radius of capillary tube is a 0.1 millimeter. That is a 0.1 into 10 raised to minus 3. That is a 10 raised to minus 4 meter. Okay. So tension is how much? 7 into 10 raised to minus 2 Newton per meter. Then angle of contact, that is a theta, is 0 degree. Then what is the density of water? It's 100. So density of water, it's 100 kg per meter. And G is how much? 9.8 meter per second. नहीं दिया होगा, then also you should do. You can use the direct formula to find क्या find करना है? Height. Okay. So these are the given. Let's move for the solution. So what is height? Height is equal to 2t cos theta by r, density, and g. Sure. Let's put the answer to 7.2 10 raised to minus 2 cos 0 degree. So what is r? It's a 1 into 10 raised to minus 4. What is the density? 1000. And what is g? 9.8. Okay. So 10 raised to minus 4, 10 raised to minus 3, 10 raised to minus 1 u. Cos 0 is 1b. So I can write 2 into 7.2 into 10 raised to minus 2 divided by 10 raised to minus 4, 10 raised to minus 3, 9.8, 10 raised to minus 4. Okay. Then what we can do? So this will become 7.2 again. It's a 7 only. Sorry, it's 7. It's 7. So this will become 14. 14 divided by 9.8. So this will become 10 raised to minus 1. So 14 sevens up, it's a 98. 98. So 14 7, 14 ones are 14, 14 sevens up, but it 198. 1 by, say, it's a 0.7. We need to 10 raised to minus 1. Okay. So you 0.1 by 0.71. So we can write 1 by 7 as it is. 1 by 7 is how much? 0.143. Yes, so 14 ones are 14, it's a 0.98. 14 sevens are 98. You can get 9.8, so it's 0.7. So 10 raised to minus 1 is 0.1 by 0.7, it's 1 by 7. 1 by 7 is 1.14. This is your height. So height is 0.143. Okay. Sure. Let's go for the next one. The horizontal force of 1 Newton is required to move metal plate. To move metal plate of an area is 10 raised to minus 2 meters square with the velocity is 2 into 10 raised to minus 2 meters per second. And when it rests on the layer of oil, 1.5 to 10 raised to minus 3 meter, to find the coefficient of viscosity. Okay. Viscosity use करना मतलब formula no different. So given क्या एक बार देख लेते हैं. Force कितना है? 1 Newton. एरिया भी दिया उन्होंने, that is a 10 raised to minus 2 meter square. कुछ चेंज करना है. Velocity दिया है 2 into 10 raised to minus 2 meter per second. ठीक है. When it rests on the layer of oil, okay, so it will become layer, so you can write x. बाद में change करना है, let's say. I was दिया है nothing. So what they require coefficient of viscosity. Coefficient of viscosity of oil, and this is represented by this term theta. ये term से represented. So for this term, what is the formula? The formula is F divided by area dV upon V. It is small change in velocity, small change in the displacement. Okay. So this will be represented dV and dx. Yeah, this is dV and dx. Just put karo, you'll get the answer. Okay. This is your formula. Sure. So in this term, coefficient is F divided by A dV by dx. So if I put all the values, F is 1, which tension area is a 10 raised to minus 2 into dV is a 2 into 10 raised to minus 2. And this is how much? This is 1.5 into 10 raised to minus 3. Okay. So if you solve it, so answer क्या आएगा? So this 1.5 will go up with 10 raised to minus 3. This is 10 raised to minus 4. 1.5. So I can write 15 into 10 raised to minus 4 divided by 2 into 10 raised to minus 4. So 10 raised to minus 4, 10 raised to minus 4, yeah, 15 by 2, that is 7.5. And this is your theta. Okay. Now even at the coefficient, uska ek unit, because all term are not same. Iska, yeah, the coefficient of viscosity of oil. Mostly coefficient का कुछ unit नहीं होता है, but this coefficient have a unit. इसका unit, that is a Newton second per meter square. Okay, what is unit? Newton second per meter square. This is a unit of the coefficient of viscosity. याद रखो, for the oil. Okay, एक ही formula use करेंगे. So this may for 1 mark or 2 mark, depends. सिंपल था. ठीक है, please go for the next one. So what they're saying, calculate the viscous force acting on the raindrop of diameter 1 millimeter falling with a uniform velocity of 2 meter per second through air. And the coefficient of viscosity of fluid is given. Okay, so we need to design the same formula. You कैसे करना है? Let's see. Just wait. See, whenever you want to find the viscous force, that time use this formula. Same formula, लेकिन थोड़ा modification आएगा. So what is the given? Given is a diameter. D दिया है ना? 1 millimeter. लेकिन हमें radius चाहिए. It's a 10 raised to minus 3 meter. So if I want to find radius, it will become d by 2. So this is a 5. It's a 10 raised to minus 3 by 2. So I can write 0.5 into 10 raised to minus 3 meter. So that is 5 into 10 raised to minus 4. ये तो हो गया radius. Velocity is a 2 meter per second. ठीक है? Then the eta is given 1.8 into 10 raised to minus 5 Newton second per meter square. Okay? Same unit use किया. And what we need to find? We need to find that force, viscous force. So that is a force. ये force मान लेते हैं. सही formula कैसे लिखने हैं? Let's go for the solution. So directly this format by this is 6 pi this coefficient r into v. Simple. So 6 into 3.14. This is 1.8 10 raised to minus 5. This is 5 into 10 raised to minus 4. This is 2. Okay. So if you multiply all the terms, so you will get the answer of 3.393 into 10 raised to minus 7. See, 5 into 2 is a 10 only. So ये 10 raised to power में convert हो. So 6 into 3 and 1.8 ये तीनों ही multiply करें. So what is the answer? So 6 into 3 is 1.8 something. This also 1.8. So easy हो जाएगा. So it's 3.393 into 10 raised to minus 7. So this is a force. So this also for 1 mark. Simple. So ये calculation करना है. बस. So 3.3 into 3.393 10 raised to minus 7 Newton because it's a force. Okay, so let's go for the next one. So next is with what terminal velocity will be an air bubble of 0.4 millimeter in diameter rise in a liquid viscosity of 0.1 Newton second per meter. मतलब ये eta ही है. And this viscous gravity is a 0.9. लेकिन यहाँ पे question mark किया. Okay, let's see. And density of air is given. First I'll get what is given. See, diameter is given. The terminal velocity with an air bubble of 0.4 millimeter in diameter. So what is the diameter? Diameter is a 0.4 millimeter. So मतलब 0.2 into 10 raised to minus 3. That is 2 into 10 raised to minus 4. This is diameter. So what is the radius? So radius is d by 2. That is 2 into 10 raised to minus 4 by 2. That is a 10 raised to minus 4 meter. Okay. Then eta is given. That is viscosity, coefficient of viscosity. 1 to 1 Newton second per meter square. Okay. I can write 10 raised to minus 1 also. Newton second per meter square. ये दोनों पॉइंट हो गए. Then what is the given density of air? That is P. It rho 1.29 kg per meter. Next thing is very important. उन्होंने दिया है specific gravity. Now specific gravity is represented by sigma. This is 0.9. But उन्होंने question mark किया because the unit is not specified. The unit is kg per meter. Okay. But यहाँ पे उन्होंने जो quantity दिया है, I think there is a typing mistake. It's a 0.9 into g per centimeter. ऐसे. It's a 0.9 g per centimeter. So g per centimeter. Convert किस में करें? kg per meter. So कैसे होगा? 0.9 into 10 raised to minus 3 kg. Centimeter is a 10 raised to minus 6 meter. So if you shift above, it will become 0.9 into 10 raised to 3 kg per meter cube. And what is your answer? It's a 900 kg per meter. So अगर kg by meter cube में दिया है, then no problem. नहीं होगा तो you need to convert from gram per centimeter cube to the kilogram per meter cube. इसमें convert करो. So answer is 900. These are the given. Okay, this is the row. This is the row. These are the given. And we need to find the terminal velocity. Okay, the formula is different. Let's see. So what is the solution? To find the terminal velocity. That is the V only. So what is the formula? V is equal to 2 by 9. Okay, formula याद करना. 2 by 9. It's not a G. 2 by 9. R square G. Okay, this is G. Rho minus sigma divided by this eta. So what will do? You put the value 2 by 9. So R square is 10 raised to minus 4. So 10 raised to minus 8. G is 9.8. We also. This one is 1.29 into 10 raised to minus into 1.29. Okay, and minus 900. मतलब also negative है, ठीक है? And divided by this eta is how much? 1 to 1. Now आपको यहाँ पे log table use करना होगा because value is not that much so easy. So you can use a log table. Okay. So let me solve some points. So 2 by 9, 9.8 divided by 1 to 1. If you subtract this one, इसका आंसर रहेगा minus 898.71 into 10 raised to minus 8. Then you need to use a log table. Okay. इसके बाद you need to use a log table. The final answer of the velocity and the velocity of the final answer is minus 0.7 to 10 raised to minus 3 per second. Okay, this is the answer. This is what you do. तो ये negative sign क्या indicate करता है? This negative sign indicate that liquid, whatever the liquid we are using, that liquid is going up. That is a rising. Whenever the sign is a positive, that indicate liquid goes down. But it's a negative, no? That indicate that negativity is indicate that liquid goes up, even in the gravity. Okay, sure. So this is negative. You can write in a sentence that why it's a negative, because it's a going up, it's a rising up. Okay. Sure. So let's go for the next one. The speed of water is 2 meters per second through the pipe of an internal diameter is 10 centimeter. And what should be the internal diameter of a nozzle for pipe? The speed is of water at a nozzle of 4 meters per second. दोनों speed दिया है and एक find out करना है diameter. So initial velocity कितना है? That is a 2 meters per second. And final velocity कितना है? That is a 4 meters per second at the nozzle. Initial diameter कितना? That is a 10 centimeter. And D2 find out करना. D2 find it. So 2 find is a D2. Okay, so let's solve. Also for one use करेंगे. See, there is one pipe only. From that flow, pipe is flowing. So nozzle पे देखना है. So for this one, you can refer the topic equations of a continuity. Mechanical property of fluid में equations of a continuity. So you can refer that section. उसमें क्या दिया? AB constant. A into B is a constant. So we have two AB na, A1, V1, A2, V2. Let's go for it. Let's see. So what is the solution here? AB is a constant, so I can write A2, V2 is equal to A1, V1. Area velocity, area velocity. Now area is given in terms of diameter. So area कैसे होता है? So pi r square. लेकिन मुझे diameter में लिखना तो कैसे होगा? R is d by 2 ना. This is pi d square by 4. So what is area here? Pi d square square. Pi d square by 4. I can use the same formula. So A2 is pi d2 का square divided by 4. And V2 pi d1 square by 4. That is V2. Now constant are pi and 4. So that will be get cancelled. So what is the remainder? We have to find d2 now. So what is the d2 square? it's a d1 square into v1 by v2. So let's put the values. d1 square is a 10. Okay, so it's a 10. Then square. v1 is 2 and v2 is 4. Okay. So let's do some multiplication. Divide by 2. So what is a d2 square? It's 100 by 2. That is 15. Okay. And then we have to find d2. Now. So d2 is square root of 50. The square root of 50 is how much? It's 7.06. If you use that log table, उसमें दिया हुआ square root का 50 का square root is 7.07. It's a centimeter because मैंने convert नहीं किया ना centimeter to meter. So d2 is in a centimeter. So if you want to convert d2 into the meter, so what is your answer? So d2 is equal to 7.07 into 10 raised to 7.07 10 raised to minus 2 meter. So your final answer. 7.07 into 10 raised to minus 2 meter. This is your final answer. Okay, this is your data. This is okay. Simple. Okay, so let's go for the next one. Only two sums are remaining. So the pressure of water inside the closed pipe is 3 into 10 raised to 5 Newton per meter square. This is 10 raised to 5. And this pressure is reduced to 2 into 10 raised to 5. Even P2. Okay. On opening the wall of the pipe. Okay, it's a wall only. It's not a value. I think it's a wall. Calculate the speed of water flowing through the pipe. Density is a given. So I can write the given. So what is the given? Given is a P1 is equal to 3 into 10 raised to 5 Newton per meter square. And what is a P2? P2 is a 2 into 10 raised to 5 Newton per meter square. And the density is also given. So densities of water is 1000 kg per meter. Okay. Calculate the speed of water flowing through the pipe. P1 P2 दिया मतलब V1 V2 होगा. We need to find the V2. The V1 दिया क्या नहीं? So V1 is zero. Initial velocity is 0. Okay. So what we need to find? We need to find V2. So let's start with the answer. So what is the solution? The formula is P1 minus P2 is equal to 1 by 2 density V2 square minus V2 square. Now initial velocity is 0. Problem. So P1 minus P2 means 3 into 10 raised to 5 minus 2 into 10 raised to 5. This is 1 by 2 and this one is 1000. V2 we need to find and this one is 0. So if I solve it, this will become 1 into 10 raised to 5. This will become 500. This is V2 square. So if I arrange it properly, so what is the V2 square? V2 square is a 10 raised to 5 divided by 500. Sure. Just check it. Need to be 1. To be cancelled. So if I take a square root, before taking square root, let's take 500. So this will get cancelled. If I take 5 ones of 4, it's a 200. So this is a 200. So V2 square is 200. So if I want to find V2 here, so V2 is square root of 200. So if I use a log table, so it's a 14.14 meter per second. Okay. So what is the V2? V2 is a 14.14 meter per second. Simple. Initial velocity is given. You have to put the much because the water is flowing. So initially the velocity is 0. And by changing the pressure, the speed may change. So V2 is a 14.14 meter per second. Okay. Sure. So let's go for the next one. Last one is remaining. Then we'll stop it. Then we talk this one. जितने sums थे exercise में ये कर. Let's see the last one. Simply last one. with the velocity, with what velocity does water flow out of an orifice in a tap with a gauge pressure is 4 × 10⁵. Before flow start, density is 1000. So, क्या दिया एक बार देखिए. See, pressure दिया हुआ. क्या दिया gauge pressure? 4 × 10⁵ Newton meters. Density दिया 1000. And बाकी कुछ नहीं दिया. Nothing is there. To find क्या करेंगे? We need to find the velocity. At with what velocity does water flow out of the orifice coming into the gauge pressure? Okay. Before the flow start, the velocity is going to find. So what is the formula of velocity? Let's see. These are the given points. See, velocity is equal to root of 2gh. G is 9.8 into 9.8 meter per second square. H is not given. So we need to find h. So there is a formula of h. You know that. It is a P upon density g. Sure? This is the formula. Now if I put this formula into V, V के अंदर मैंने formula put किया. What is h? P divided by g. G get cancelled. So what is the new formula? 2P upon density. So this is your formula. So let's put the values. So what is a P here? 4 × 10⁵. And this is 1000 now. So this will become 8. And 10⁵ and 10⁵. This will become 10⁵. Okay. So ये solve करना. So V is equal to square root of 8 √ 10. So erase all the things. So क्या था? Velocity is equal to 8 × 10⁵. So square root of 8 × 10. And what is the square root of 8? Anyone? Square root of 8? It's 2.828 into 10. You can use a log table. So you get a 28.28 meter per second. This is velocity. Simple one. Okay, let's go through. Okay, so here we're done with all the sums of the mechanical properties of fluids. We can go through this topic. Formula based sum. If you know the given to find and which formula you need to use, you can easily find. And एक ही दो सम में we've got a log table. कुछ भी you can easily go through it. Okay, so just go through it. We'll stop it. Okay? Thank you. Stop it.